Hello everyone. Hey guys, today we are going to deal with another topic which is going to be an amazing, which is the resonance stability. So what is this resonance stability and why we are learning this topic? Let's have a look. Guys, usually for the JEE means paper, we will be asked with such a questions like here. Compare the relative stability of the following resonating structure. You would be given with the resonating structures, as you know, if there would be a resonance, there will be many resonating structures or the canonical structures that we could say. So out of all the following structures, which is going to be the most stable? Just like if you will break this particular bond, you will be getting the second as the resonating structure, O negative and positive. And if your pi bond will be going like this, if you will be forming a bond like this and this pi bond will go like this, you will be getting the third as the resonating structure. See, here you will be getting a positive charge because of the delocalization of electron. There will be a formation of a pi bond, and then after this pi bond will be broken and you will be getting a negative charge. So in short, all the three are the canonical structures or the resonating structures of each other. Now the question is asking about the relative stability out of all, which is more stable, because whichever the structure will be more stable can only give us the answers for many such questions like what would be the bond order in the molecule, what would be the hybridization, okay, what would be the bond angle. So all such questions related to the bond angle, bond order or hybridization can only be calculated from the most stable structure. So this is an important topic that we come across. So now let's have a look at how we can find out the resonance stability criteria. What is the criteria to find out the most stable structure? So here on the very first slide, as you can see from the question number 1 which I have taken for you, here we have two structures, the structure number 1 and the structure number 2. These two are the resonating structures of each other and we need to know that which is the most stable structure. So here I have pointed out few of the points, and these are the points that we have to follow in a specific order. Yes, we can't go with any of the point anytime. No, we have to follow a specific order. We have to move from top to bottom. So this means that, let me make you understand. So the first point says that the neutral with complete octet means any structure which is neutral and having its octet complete is only going to be a most stable structure. Okay, so if you would see this particular molecule, out of these two structures, no one is neutral, and if it is all about the octet, let us check their octet. Guys, you know carbocation. So whenever we have a positive charge over a carbon, so carbon has how many valential electrons? 4 valential electrons, but because of this positive charge there will be a deficiency of 1 electron, 4 minus 1. Now this carbon is forming how many bonds? This carbon is forming, so these are the valential electrons minus the charge. I have subtracted the charge V minus C plus number of electrons participating in the sharing. Okay, in how many electrons are participating in the bond formation? Carbon is forming 2 bonds with hydrogen and 1 with oxygen. So ultimately 3 electrons it is getting from sharing. By sharing, okay, by sharing how many electrons it is getting, that is 4 minus 1 is 3 plus 3 means this is a 6 electron species. As we already know, every carbocation is a 6 electron species. Please bear me with this pen, I really don't know why this happens on the very first slide of the session. Now if you look for this particular oxygen, the particular oxygen is having the 6 valential electrons, 6 valential electrons and 6 plus, please focus over what I am saying, 6 plus how many electrons it is getting from the sharing? 2. So 6 plus 2 comes out to be 8. Its octet is complete. Now here if you would see over this particular carbon, its octet is complete. We can see that carbon is having 4 electrons and 4 it is getting from the sharing of electron. 3 from hydrogen and 1 from oxygen. So 4 plus 4 comes out to be 8. So we found that here we have 6, here we have 8 and here we have 8. So means octet is not complete. Now let's look for the second structure, whether its octet is complete or not. Guys, if you will see over this particular carbon, this is having 4 electrons and 1, 2, 2 from hydrogen and 2 from this double bond. 4 electron it is getting from the sharing of electrons. So means 4 plus 4 is 8. Okay, but here if you will see over the oxygen, please Focus, this is 8. Now focus over the oxygen. Guys, you know oxygen has 6 valence shell electron, and because of this positive charge you have to do -1. There will be a subtraction of 1 electron, loss of 1 electron. Now this oxygen is forming a one bond with carbon and two double bonds. This means how many number of bonds are forming? 1, 2, 3. 3 bonds are forming. So 6 minus 1 is 5. 5 plus 3, please focus, it's 3. 6 minus 1 is 5 plus 3 means it is 8. So I just calculated their octet, and here the octet of this oxygen is complete. It has 8 electrons. If you will look for this particular carbon, of course it's very easy to solve because the carbon has 4 valence shell electron. There is no charge, so no addition or loss of electron, and 1 electron it is getting from the oxygen, and 3 electrons the carbon is getting from the 3 hydrogens, means forming 4 bonds. So 4 bonds means 4 electrons. Ultimately this will become the 8 electron. So all are the 8 electron species. Guys, from the first criteria, only from the first criteria, neutral with complete octet. So no one is neutral, okay, fine. Then we move to the second part, that is the complete octet. Okay, so we found that here the octet is complete, here the octet is complete, here in this question the octet is complete. So second structure is more stable than the first one. Are you getting my point? Second is more stable. Just from the very simple one single point we got our answer, that is the second is going to be more stable than the first. Why not first? Because if you would see the first structure, you will find that here we do have a 6 electron species. So this is not obeying the octet rule, its octet is not complete, so this is not stable. We need not to go over the other points, because if we are getting our answer from the very first point, no need to obey, no need to go beyond that. Now, with the help of the another example, I will be telling you that what could happen. Now, if you would see the question number 2, you will observe that here we have 1, 2, 3 and 4 molecules. Okay, if you would see, we need to find out the neutral with complete octet. Guys, please, will you be able to find out the neutral with complete octet? Yeah, as you all can see, the structure number 1 is very neutral. Yeah, the structure number 1 is very neutral. We can see that it's completely neutral. There is no charge, no positive, no negative charge. This is what neutrality is. Now, we do have a complete octet. Yes, every carbon is forming 4 bonds. We know that carbon is a tetravalent. It must have 4 bonds. So yes, a carbon is forming 2 double bonds to hide with hydrogen, 1, 2, 3 and 4. If you will see over this carbon, it is also forming 4 bonds, one with this, 2 and one with the another hydrogen. This is also forming 4 bonds. So here we found that its octet is complete. This is also an 8 electron species. This is also an 8 electron species, and this is also an 8 electron species. So all the carbons are 8 electron, and this is a neutral. So we found that the first is going to be the most stable structure. Okay, now what happened for the second, third and fourth? Let's see. They are charged, but are their octet complete or incomplete? Guys, let me tell you, whenever you will be having a carbocation, so usually carbocations are the 6 electron species, because there will be a deficiency of 1 electron. So they will actually become, they will be having only 4, they are having the 4 valence shell electrons. So if you do the loss of 1 electron, they will become 3. So they can have a maximum possibility to share only 3 electrons. That's why they are always 6 electron species. And the carbanions, they usually have 4 electrons, okay, and 4 plus carbanions if I am talking about, and because of this negative charge they gain 1 electron. 4 plus 1, 5. Now they have a maximum possibility to share 3 electrons only, because to complete their octet they just need 3 electrons. So I want to say this, guys, ki carbocations are the 6 electron species and the carbanions are the 8 electron species. Okay, if you don't know this, I will also be discussing the same part in one of my another session. Okay, when I will be taking your reaction intermediates or the stability of the carbocations and carbanions. Okay, so here what is happening, this is a 8 electron species, this is also 8 electron, this is also 8 electron, but here the carbon with a positive charge is a 6 electron species. Here also we will find that carbon with a negative charge is a 8 electron species, carbon with a positive is 6 electron, carbon neutral is an 8 electron species, and here this carbon is also 8 electron. Okay, so here the octet is incomplete, here also the octet is incomplete. If you will see this particular part, this is again a 6 electron species. You please write it with me. This is an 8 electron species, this is the 8 electron species, and this is also the 8 electron species. Okay, so I am just calculating their octet, what about their octet is. Okay, so we found that this is 6 electron, this is 6 electron, and this is 6 electron. So all the three are 6 electron species. So ultimately their octet is not complete. Okay, so first we found that this is more stable, but out of the second, third and fourth, they are not, their octet is not complete. Then how we will be getting an answer? We have to move to the second point, that is more bond order. More bond order means more number of covalent bonds. More number of covalent bonds. The bond order has to be higher. Okay, if you will see the bond order between the carbon-carbon bonds, you will find that it is 1 bond, 2, 3 and 4. How many number of covalent bonds are there? 4 between the carbon-carbon. Here if you will count 1, 2, 3 and 4, 4 covalent bonds. Here we also found 1, 2, 3 and 4, means 4 covalent bonds. So covalent bonds are also the same. We are not getting our answer from this particular point, that is the second point. Now we will be moving ahead with the another point, that is the opposite attracts like repels. What does this mean? Means whenever we will be having opposite charges closer, they will attract and they will be forming a stronger bond, and the like charges has to be away. I mean to say that opposite charges must be close, opposite has to be close, and the like has to be away from each other. Okay, why? Because opposite usually attracts and like usually repels. So that's how opposite charges has to be closer and the like charges has to be away from each other. Ultimately, what we observe is, we observe that here if we will look in the structure number third, in the structure number third, the negative charge and the positive charge are very close to each other. Please have a look, they are closer. Okay, but if you will see the structure number second, here the opposite charges are away. And if you will see the structure number 4, here also the opposite charges are closer. So now please focus, out of the third, fourth and out of the second, third and fourth, which is going to be the most stable structure? Think about it and do let me know what could be the right answer. Out of the structure number second, third and fourth, which is going to be the most stable structure? As per the rule, opposite charges has to be closer because they attracts and form a bond. So here we can say that the third and fourth are going to be the most stable structure rather than the second. Why? What is the reason? Because in the third and fourth structure, the opposite charges are closer, these charges are closer, but in the third structure, these charges are very, very far away from each other. So this is not a considerable condition. Okay, so second is going to be the least stable. Now out of the third and fourth, we have to decide, okay, what will be the order? Now this is what we have to decide. Now the question says that charge as per the nature of the atom, means charge has to be as per the nature of the atom. Means if you are having a positive charge, the positive charge should be over the electropositive atom. Electropositive atom, just like you can put a positive charge over Na, you can put a positive charge over the lithium, okay, any metal which is electropositive, and the negative charge has to be over the electronegative atom, just like over the oxygen, over the nitrogen we could have a negative charge, over the fluorine or chlorine, the electronegative atoms, we could have a negative charge. Okay, so means the charge must be as per the nature of the atom. If an atom is electronegative, it must carry a negative charge, and if an atom is electropositive, it must carry a positive charge. Okay, so this is the point. Now we can also follow Arehi. Okay, what do you mean by Arehi? Arehi, guys, Arehi means A is for aromatic, A is for aromatic, E is for electronic or electromeric factor. Okay, and R is for resonance, R is for resonance, and H is for hyperconjugation, hyperconjugation. So this is short form. I is for inductive. Okay, guys, I have given you all these points in detail here as well, so you need not to be worried. Okay, so A is for aromatic, E is for the electronic factor or the electron density factor or the overlapping factor, what it is going, R is for the resonance factor, that is the mesomeric factor you can consider. H is for the hyperconjugation and I is for the inductive effect. Okay, so this is the point number 5. So if we follow this concept, so what does this mean? This means that if your any of the structure is aromatic, it has to be more stable. If Okay, so out of all these questions, do we have second and third and fourth structure? Are they aromatic? No, they are not aromatic. So the A factor, that is the aromatic, no. Out of third and fourth, no one is aromatic. So we are not following that. E, electronic factor or the overlapping factor. If we will see the overlap, yeah, we will be having a same type of overlap. Here also the carbon-carbon overlap, the carbon-carbon overlap. So we have a same kind of overlap. The resonance factor or the mesomeric factor. Resonance factor or delocalization, the same delocalization is happening here, the same kind of delocalization is happening here. So no, this is also not working. The hyperconjugation and the inductive effect. So these are the other factors that we have to see. The hyperconjugation and the inductive effect. Now guys, you know ki out of all those factors, none of the factor is working. But if you will come to the next point, that is the stability of intermediates. If you will see the stability of intermediates, you know what are intermediates? Intermediates are carbocations, carbanions and radicals. So we have to consider the stability of the carbocation, carbanion and the free radicals. Okay, so if we will obey the stability of the reaction intermediates, then will be able to solve the question. Now let's come over the question. Here over the question you will find that this particular carbon is having 2 and 1, that is 3 alpha hydrogens to stabilize it. But if you will see this as a carbocation, this is having only 1 alpha hydrogen to stabilize it. Guys, this is the 2-degree carbocation and this is a 1-degree carbocation. So if I ask you about the stability of the reaction intermediates, your answer would be, ma'am, 2-degree carbocation is much stable than the 1-degree because of the more number of alpha hydrogens. Okay, yeah, resonance, they both are resonance stabilized. If you will see the both of them, okay, this is also resonance stabilized, but here this is getting more, this is a more stable carbocation. So because of that certain reason, third is going to be the more stable than the fourth one. So this is going to be our order. Okay. And then the last point says that more number of benzene ring. Basically this is a freeze rule. Freeze rule says that as and when the number of benzene rings will increase in the case of the benzonoid system. Okay, sometimes we do have systems like anthracene, phenanthracene, benzene, where we have one or more than one benzene ring. So whenever we will be having more number of benzene ring, that will lead to the more stability. But the whole thing is we have to follow this priority order. Okay, you can say that priority order. Okay, this is your priority order. So the first priority will be given to the point number 1, that is a neutral with complete octet. The priority number 2 will be given to the more number of bond orders, that is there must be the more number of covalent bonds. The third priority should be given to the opposite attracts and like repels, that is the opposite charges has to be closer while the like charges has to be away from each other. The fourth point has to be the charges must be as per the nature of the atom. If an atom is electropositive, it must bear a positive charge. If an atom is electronegative, it must bear a negative charge. Follow ARAHE, a short form. Short form is A for aromatic. If you find that if any of the structure is cyclic, having delocalization of pi electron, is planar as well and following the Huckel rule, everything is there. So yeah, it is aromatic, and because of this aromaticity, it will be stable. Then the other with the overlapping factor or the back bonding factor. Then comes your R, that is the resonance factor. Then comes your hyperconjugation and then the inductive. If the array is also not getting obeyed, then you please move on to the another point, that is the point number 6, that is the stability of intermediates. Intermediates are usually carbocations, carbanions and radicals. So out of all the 3 intermediates, whatever the intermediate you have, check out its stability order. Now the last point is, whenever you have such a compounds where we have more than one benzene ring, now among all the structures, that particular structure will be more stable where we will be having more number of benzene rings. Okay, so guys, in short, I have given you all these 7 points. So if you will follow these 7 points in that priority order, you will be able to solve your question. Okay, so all these points you will also be getting the PDF of this particular session through the description. Okay, so please ping me up, give your answer in the chat section, absolutely, in the comment section, that what you want its PDF or any other thing, whatever the help you are looking for, I will definitely do that for you. Okay, so guys, my whole aim is you please go through these rules. Okay, whatever I have like explained you is given in this particular slide. Okay, so what are the factors, how we have to follow and why we have to follow? Because, okay, let me tell you why we have to follow. Because guys, usually whenever there will be a resonance leads to more stability. Okay, so if we will be able to know that, okay, out of these three resonating structure, this particular structure is most stable, means that particular structure is going to be the most stable. Okay, and that particular structure is only going to decide your bond order. Because of the resonance is a game changer. It changes your bond order, it changes your bond angle, it changes your hybridization, it changes your bond length. Yes, I hope you know about it. Resonance is a game changer. Because of the resonance, many such answers like that is on the bond order, bond angles, hybridization, bond length gets changed. Okay, so if you know that what is the correct answer for all such questions, you need to know the most stable structure. Okay, so whichever be the most stable structure or the resonance hybrid structure is only going to decide what would be the answer for the bond order, what would be the answer for the bond angle, hybridization or bond length, and so on. So now for today, our whole focus is over to determine the resonance stability. Now, this is the question number 1 that I want you to do, guys. Okay, and do let me know what would be the order for the resonance stability among all the three resonating structures. If you would see this, our first point says that neutral with complete octet. Neutral with a complete octet. So find it. Do we have any structure which is neutral and its octet is complete? Yes. My eyes has watched this particular option. That is the option number 1. I can see that in the option number 1. Let me change the color because students has suggested me, ma'am, please avoid using red color because it's not visible. So yeah, I'll be using yellow color. Okay, so if you will be seeing the structure number 1, we can say that the structure number 1 has to be more stable because it's neutral, and I hope its octet is also complete, right? Yeah, the carbon is having 4 valence shell electrons, and after the 4 valence shell electrons, it is also forming 1, 2, 3, 4, 4. So 4 plus 4 is going to be the 8. Nitrogen is having 5 valence shell electrons, and after 5, 3 are undergoing sharing. So 5 plus 3 is 8. So yeah, of course, here also if I will be looking for this particular carbon is having 4 valence shell electron, forming 1, 2, 3, and one bond will also be with this carbon, forming 4 bonds. So 4 plus 4 is going to be the 8. Yes, I think, yeah, every atom is like is complete in its octet. Okay, so neutral and a complete octet. So that's why the first is going to be the most stable. Okay, so now what is the second point that we have to see? We have to see the second point, which says that more number of bond order. That is the bond order. Bond order has to be high. More number of bond order has to be there. Now guys, out of all this, just by knowing that the first is going to be the most stable, we can apply the elimination method and we can say that the answer could be either A, okay, or the answer could be either C, right? These two could be the probable answers. Now we just have to find out of second and third which is more stable. So irrespective of moving on to the step number 2, yes, irrespective of moving on with the priority order 2, let us see, okay, these are the charged species, but what about their octet? Let's have a look over their octet, then after we will be moving ahead. Are you getting a point? So it would be nice if you will see, if you will focus over this nitrogen. So guys, nitrogen is having a 5 valence shell electrons plus 3 electrons it is getting from the sharing. So 5 plus 3 comes out to be 8. This carbon 4 are from sharing, so 4 plus 4 is 8. This carbon 4 and 4 are from sharing, so 4 plus 4 is 8. This carbon again the carbon is having the 4 electrons, and 1 2 3, of course 1 we will be having the hydrogen to balance its valency. So 4 plus 4 is going to be the 8. If you will look for this particular carbocation, guys, this is a carbocation. So carbocation are usually 6 electron species, and you can even calculate it. Why you can calculate it? See, here over the carbon we will be having a 4 minus 1, and only 3 electrons are undergo sharing. So 4 minus, this is a 6 electron species. For the oxygen, if you want to calculate 6 plus 1, because of this negative charge, 1 from sharing, then it is an 8 electron species. So we found that everywhere the octet is complete, except the one of the carbon, that is this. Only at this particular carbon we do have a 6 electron species. This is a 6 electron species. Is it clear? And rest the octet is complete. Now let's have a look over this particular question. If you will see the option number 3rd, so you guys, you will find that over the nitrogen we do have a negative charge here. Let me rub this part so that you will be able to see the negative charge. Okay, so yeah, so over this nitrogen we have a 5 valence shell electron. After the 5 valence shell electron, there is a negative charge, means plus 1 plus 2 are from sharing. So 5 over 6, and then it is an 8 electron species. Yeah, it is time taking, but slowly when you will practice, you will be able to speed up. Okay, so this is what I could say, and please do this. Okay, so carbon, yeah, the carbon is having the 4 valence shell electron, and 4 it is getting from sharing. So 4 plus 4 is 8. Now let's have a look over this carbon. Of course it's a carbocation. This is again going to be a 6 electron species, because carbocations are 6 electron species, and rest the octets are complete. Only the major atoms I am looking at, not all, because yeah, this is how we could save our time. Okay, so we know that the carbocations are the 6 electron species. So this is again a 6 electron center. Here also we do have a 6 electron. So means that it's very clear that out of the second and out of the third, their octet is incomplete. Octet incomplete. Okay, now we can move on to the second point. Now you tell me what is the second point? The second point says that more number of bond order, means must have more number of covalent bonds. What is the second point? We must have more number of covalent bonds. So can you please calculate the covalent bonds? Okay, between the carbon only. So this is a 1 bond, 2 3 4 5 6 7 8 9 and 10. So here we found that bond order is going to be 10. I just found the bonds between the carbon, all the bonds which have been written. So this is a 1 2 3 4 5 6 7 8 9 and 10. 10 is the bond order. Okay, here if you will see, this is 1 2 3 4 5 6 7 8 9 and 10. Oh, again the bond order is 10. So are we getting any conclusion from the point number 2? No, leave it. Now the third point. What is the third point that says? The third point says that if you have a charged species, then the charges must be closer. Matlab the opposite charges must be closer. Opposite must be closer, and the like must be away from each other. Why? Because like repels and opposite attracts. So opposite has to be closer. So can you please have a look that where do we have a charge? Where do we have a charge? So if you will see the structure number 1, you will find that we do have a charge at this particular carbon and this particular oxygen. So they are this much away from each other. Okay, and here if you would see, this is negative and this is positive. So if you will see the charge separation, the opposite has to be closer, then only there will be more stability. So from this particular point number 3rd, we can say that the structure number 2 has to be more stable than the 3rd. So why we are saying that the structure number 2nd is more stable than the 3rd? Because in the structure number 2, opposite attracts, opposites are closer, and when the opposite attracts, there will be a bond formation, and hence there will be more stability. So are you getting? Now we can say that the right answer for the question is option number A. Okay, so this is the way how we have to follow the priority order. So these were the points though. Neutral structure, only 7 points that we have to keep on our tips. Okay, neutral with complete octet, more bond order, opposite must be closer, like must be away, because opposite attracts, like repels. Then if you are having a charge, charge must be as per the nature of the atom. Then follow the array, then the stability of the intermediates, and in the last, if you have a compound with more number of benzene rings, count the number of benzene rings. Okay, so these are the 7 points. These are the 7 points that you have to follow in a priority order. Now we do have a question number 2, and in the question number 2 you have this molecule, and the question is saying that most stable canonical structure of the given molecule. So all these are the canonical structures or the resonating structures. So out of all this, which is going to be the most stable? So first of all, what we have to see, of course they are not neutral. Okay, so the first point is, okay, if not neutral, at least find their octet. Okay, look for their complete octet. Do they have a complete octet or not? So let us have a look whether they do have a complete octet or not. So guys, when you will see, this is a carbonyl. Carbonyls are usually the 8 electron species, oxygen with a positive charge. So wherever you have a charge, just find the octet rule there. So oxygen is having a 6 valence shell electron. Because of the positive charge, there will be a loss of electron -1, and oxygen is forming 1, 2 and 3 bonds. So 6 minus 1 is 5, and its total is going to be the 8. So yeah, it's a 8 electron species. If you will see over this particular carbon, we know that the carbonyls are the 8 electron species, because again, if you want to calculate, you may calculate. Carbon have 4, -1 means there will be addition of 1 more electron, and it is forming 1, 2, 3. 1, 2, 3. So means how many bonds? 3 bonds. 4, 1, 5, 6, 7, 8. Octet complete. Over this oxygen, just now we have calculated for this particular oxygen octet complete. So yeah, here also the octet is complete. If you will see over this particular carbonyl, its octet is complete. As I told you, carbonyls are 8 electron species. Oxygen, its octet is also complete. It's a valence shell electron 6 plus, is there any charge? No charge. There are only 2 bonds. So 6 plus 2 is 8. This is an 8 electron species. But if you will see over this particular carbon, this is carbocation, and carbocations are 6 electron species. Here all the atoms, every atom is octet complete. Here the octet is complete, but here, because this is a carbocation and carbocations are 6 electron species, if you want to calculate, you may. Carbon having 4 electrons, because of the positive charge there will be a loss of 1 electron, and forming 3 bonds means 3 more electrons. Ultimately this comes out to be a 6 electron species. Okay, now the option number D, in the option number D we can say that again this is a carbocation. Okay, I am just looking for its octet. I am not saying that this carbocation is unstable. Okay, I know that the carbocation is stable because of the resonance, but I am just finding out its octet. Okay, so please look over which point we are looking. We are looking for the octet, so just simply focus over the octet. Okay, as we already know, they all are the resonating structures. So of course, they all have a resonance involved. So this is a carbon with a positive charge, again going to be a 6 electron species. Carbon with a negative charge is an 8 electron species. This oxygen, because over this oxygen, what we know is oxygen is a 6 electron species, plus how many bonds this oxygen is forming. Let's have a look. Now guys, you would be amazed to see this oxygen is having a 6 valence shell electron, but this oxygen is forming 3 bonds. So it is going beyond that, 9 electrons. Now you see, can a carbon can form a 5 bonds? Have you ever seen a carbon forming 5 bonds? 1, 2, 3, 4, 5. 5 bonds. No. So this carbon is also very, very unstable. This carbon is having 4 valence shell electron, but other than that it is taking part in the formation of 1, 2, 3. So basically for such kind of molecules, what we have to do is, let me tell you, we have to do the charge separation in such molecules, okay, because otherwise they will never be stable. So for such molecules, whenever we have this kind of double bond, we will apply the electromeric effect, and then we will be putting a bond together. So ultimately what we will be doing, we will be breaking a pi bond, and they will be going like this. Otherwise this specific structure is unstable because its octet is not complete. Okay, and we will be getting it like this. This is O, this is your negative charge, this is your positive charge, and here you will be getting this. Here we will prefer to keep a negative, and here we will prefer to keep a positive. Okay, so this would be the structure. So what I have done is I have just applied the electromeric effect, and I have broken this particular bond, and after the formation breaking of this bond, I have given a charge, that is the positive and negative. These are known as the fused rings. Okay, now why I did that? I could also do the negative or positive, because when I will be making this as negative, this will become an aromatic ring. See, this is an aromatic ring. This ring is aromatic, no, because this is having a 6 pi electron system, 6 pi electron system obeying the Huckel rule. That's why I did a charge separation in such a way. Okay, now, but our question is something different. Our question is, which of the following is going to be the most stable or the most stable canonical structure? Okay, so guys, out of all these structures, we found that there were only two structures with complete octet and the two structures with incomplete octet. So we came to a conclusion. That the structure number A and B has to be more stable than the structure number C and D. Why? Because in the A and B octet complete, and in the structure number C and D octet incomplete. Got it? This is the conclusion that we have drawn. Now, I know that you people have reached to your answer, but still let's have a wait, because we do have some other students also, those who are still not getting the right answer. So let's wait for them. Now, after the octet complete, the second point that we have to look for the bond order. The bond order has to be higher. Okay, now if you will see the number of covalent bonds, then you please find it out what could be the right answer. We have 1, 2, 3, 4, 5, 6, of course, 1, 2, 3, 4, 5, 6, this is 7, this is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 is the bond order. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9, I hope I am right. 6, 7, 8, 9, yeah, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 is the bond order. Here also the bond order is 17 and 17. My question is the most stable structure. 17, 17. I am not getting over any conclusion. The third point says that if you have a charges, then the opposite charges must be closer and the like must be away. So if you would see the charges, you will find that here this is x, y, z, 3 atoms away, this is also 3 atoms away. Okay, so no conclusion that we are drawing, no conclusion. So from the point number 3rd, that is the charges, that is the opposite closer and opposite away. Are we getting any conclusion? No, we are not getting any conclusion. They all are closer. So now we will be moving ahead with the point number 4. The charges must be as per the nature of the atom. So are the charges as per the nature of the atom? Over the oxygen we do have a positive charge, and here also we do have a positive charge. This is a carbon with a negative charge. This is again a carbon with a negative charge. No conclusion drawn. Charge as per nature of atom. As per nature of atom. Yeah, they are as per nature of atom. No, both are having the oxygen with a positive charge. Now we will come to the another point. What was the point number 5? The point number 5 was Arehi. Just focus the point number 5. After the point number 5, we have to follow the Arehi. So what is this Arehi is? Arehi is A-E-R-H-I. A-E-R-H-I. Now follow Arehi. So if I follow Arehi, I might get to any conclusion. Guys, see, in the case of the Arehi, what will happen? This and this, if you will see the two structures, you will find that here in the option number B, this particular ring is aromatic. Have a look. This is an aromatic ring. See why? Because this is a closed cyclic ring. This is a closed cyclic ring. Closed cyclic ring, which is also planar. planar, here we can see the delocalization, the complete delocalization of pi electrons. Okay, delocalization is also there. And how many electrons? 6 pi electrons. And 6 pi electrons actually follow the Huckel rule, which is 4n plus 2 pi electron rule. If we put the n is equals to 1. Okay, so yeah, this is aromatic, but is this aromatic? No. And even if you will see this particular ring, this is also aromatic. Why is this aromatic? Please, you do have a look there why it is aromatic, because here also we have a complete delocalization of pi electron in this particular ring. Okay, we do have a complete delocalization of pi electron. So as per the A, because of this A, the structure number B is more stable irrespective of the structure number A. So here we can say that out of B and A, B is more stable than A. B is more stable than A. Why? Because B is an aromatic ring. Okay, so my order will be aromatic. Because of the aromatic, B is more stable. Then comes your A. Okay, then comes your A. And if you will compare between the other part, if you will compare between the C and D, then what will happen among the C and D? Guys, here you have noticed that this is also a 6 electron species and this is also a 6 electron species, but if you will see, you will find that, okay, what about the bond order? Let's have a look over the bond order. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 16 bond order. Okay, so here we was getting 17, that's why A and B were more stable. And here we are getting 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. This is 17. So which is more stable? So which is more stable? This pi bond we could be broken like this, and hence it's becoming more stable. 17. So we can say that D is more stable than C. I hope I have counted the bond order correctly. Let us do one more time. This is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Yeah, it's 16. Okay, so yeah, now you understood. Here in the case of A, the bond order is 17. In the case of B, the bond order is 17. In the case of D, the bond order is 17. So of course they all the three are having the bond order as 17. So ultimately they have to be more stable than the C. C is the least stable compound. C is the least stable compound. Okay, so this is the way how you have to solve the questions related to this resonance stability. Please, right now you are thinking that it is taking a lot of time, but yeah, slowly and slowly, once you will practice, you will be able to understand it. Okay, and ultimately for 4 marks in our JEE mains paper, this all much is required. So here we do have a question number 3. Let's have a look what we can do for this particular question. Here this is there, we do have 3 structures, structure number 1, structure number 2 and the structure number 3. Okay, the very first point, the question is asking which is not a valid canonical structure, means which is not a valid canonical structure. So how would you answer? Means which is the least stable structure will not be a valid canonical structure actually. Not valid, or you can say that the least stable. Okay, least stable. Okay, so let's find out the stability order. Okay, let's see. So here they all are neutral over the nitrogen. Let's find the number of electrons over the nitrogen. Nitrogen has 5 valential electrons, minus 1 because of the positive charge, and it will be having 3 bonded pairs. So 5 minus 1 is 4 plus 3. 5 minus 1 plus 3 means, no, sorry, not 3, 4, because 3 with hydrogen and 1 with carbon, 4 bonds, sorry. So 5 minus 1 plus 4. Yeah, we know that the ammonium ion exists now. So that is 4 and 4, 8. Yeah, this is an 8 electron species. Carbocations are usually 6 electron. Carbon, this is an 8 electron species. Ammonium ion we just calculated, it is an 8. 5 minus 1, 4 plus 4, that is 8. Yeah, it's an 8 electron species. If you will see there, this is again 6 electron. This carbon is 8, everyone is 8. Now guys, we can easily see in the structure number 1, the octet is complete. Octet complete. and in the structure number 2 and 3, the octet is incomplete. Incomplete octet. Incomplete octet. So because of this incomplete octet, the second and third are going to be the less stable structures. Okay, so first is more stable from the very first point, that is neutral with complete octet. Yeah, but no one is neutral, no one is neutral. So that's how we will say neutral with a complete octet. If no one is neutral, okay, let's have a look for the complete octet. Okay, now the second point says that count the number of bond orders. Count the number of bond orders, the bonds which are visible to you. 1, 2, 3. So first is stable, so there is no point of comparing in this structure number 1. If first is stable, means it's stable. Okay, now there is no point of like looking for the any other factor in the structure number 1. Now we will be looking for the structure number 2 and 3. Here the bond order is 1, 2, 3, 4, 5. Bond order is 5. How many number of bonds are there? 1, 2, 3, 4, 5 and 6. Here the bond order is 6. You can calculate it again. 1, 2, 3, 4, 5. So bond order is 5 and here 1, 2, 3, 4, 5, 6. Bond order is 6. So which is more stable? Out of 3 and 2, we can say that 3 is more stable than 2. More will be the bonds, more will be the attraction, more will be the stability. So first, because of complete octet, out of second and third, third is more stable because of bond order. Bond order, that is 6, rather than here the bond order, that is 5. Okay, ultimately which is the least stable structure? That is the second is the least stable structure. Least stable. So which of the following canonical structure will not a valid structure? That is, the answer is option number 2. So this structure is not possible. Okay, this is not a valid canonical structure. Clear to everyone? Okay, that is the option number 2. Clear? Here we do have 2 more questions for you, so have a bit of patience and let's do it today itself. And after this particular session, you need not to watch it or you need not to do any other thing for this, because everything, every example, every practice you are getting from this session only. Okay, so yeah, it has to be a like from 0 to 100 we have to do in this particular session only. Now guys, you please keep commenting in the chat section that are you actually learning from this session or not. If you have any doubt in any of the question, you want to know any further the further thing, please you do let me know. I will completely come up with one more session on this. And yeah, so whatever will be your viewpoint, whether it is a positive or a negative feedback, please keep giving me. Okay, that's your love. Please do share it with me. Now here we are for the very fourth question. What does it says? You have to find out the correct order of stability for the given canonical structure. Again, the stability, the concept of stability. Let's have a look. If you will see, okay, everything is neutral. This is a carbon with negative, and yeah, the carbon ions are 8 electron species. So for the very first point, no one is neutral. Okay, let's look for complete octet. Let's look for complete octet. Its octet is complete. Now this is a carbon with a positive charge. Oh my god, you are a 6 electron species. Here oxygen, 6 plus 1 plus 1, that is 8. This carbon is 4 plus 1 plus 3. 2 with hydrogen, 1 with carbon, means 8. But here this carbon is a 6 electron species. Now when you will look for this particular thing, this carbon is 4 forming 4 bonds, 8, oxygen 6 plus 1 with the bond 8. Yeah, this is also 8 electron species. Guys, we found that the conclusion that we have drawn is the first and third are going to be more stable. Sorry. Yeah, first and third are going to be the more stable than the second. Why? Second octet is incomplete. Incomplete octet. There we have a 6 electron species. Incomplete octet. While in the first and third, octet is complete. Now compare between the first and third. So now this is the question that we have to do. compare between the first and third. So if you will compare, you will find that from which particular point we can do bond order. Yeah, this is the second point, bond order. So 1 2 3 4, the bond order is 4. Here first and third, now 1 2 3 4, again the bond order is 4. So we are not coming to any conclusion. What would be the next point? Next point is charges must be away, or like must be away, opposite must be closer, and the like must be away, and the like must be away. So this was our third point. Is this valid for any of the structures? Structure number 1 and third, there we have only one charge, that is negative. There we have only one charge, no two charges. So no, this point is also not valid. The fourth point is charges must be as per the nature of atom. Charge must be as per nature of atom. So if you will go with this particular pointer, what do you conclude? Here we have in the structure number first, we have a negative charge over the carbon. In the structure number third, we have a negative charge over the oxygen, so which is stable. Guys, out of carbon and oxygen, oxygen is more electronegative. Oxygen is more electronegative, and the negative charge over an electronegative atom is actually stable. So oxygen being more electronegative species bear a negative charge more stably. Okay, so the third structure is going to be the most stable. So third, you come over there. So third is going to be the most stable, then the first, and then the second. Why third? Because here we have a negative charge over oxygen is more stable than in the second. So out of the correct order is 3 1 2. So what is the right answer for this question? That is the option number B. So what I'm again and again doing, I'm moving on to every criteria. I'm just following a priority order for the resonance stability criteria. Okay, the first point, the second point, the third point, then the fourth point, then only I'm moving. Okay, I'm not doing a hurry, just like I'm jumping over the point number 4, I'm jumping over the point number 6. No, we should not do that. Okay, so this is the portion where we did a mistake and we got our answer wrong. So this is the point where you have to be a little bit more careful. Now this would be the last question, guys, that we will be doing all together. The correct stability order of the following canonical structures, means we have 1 2 3 three resonating structures, and we have to find out the stability order. First of all, look for the octet. Ma'am, the first point is very difficult. Oh my god, octet. It's very difficult to find out how many number of electrons would be there. No issues, guys. Just focus over the species which are specifically charged. Okay. So now if you will be looking for the oxygen, this is having 6 valence shell electron, repeating 6 valence shell electron minus 1 because of the positive charge. Then how many bonds it is forming? 1, 2, 3. So plus 3. Ultimately, this is 5, 6 minus 1 is 5, plus 3 is 8. This is an 8 electron species. Look for the carbon. Guys, carbons are always 6 electron because we know 4 electron minus 1. 4, after 4, if you will be having a positive charge, you have to do the loss of 1 electron, and then after 1, 2, 3, 3 bonds are getting formed. So 4 minus 3 is 3, plus 3 is 6 electron. So yeah, they are always 6 electron species. Nitrogen, just have a look over the nitrogen. Nitrogen is having a 5 valence shell electron minus 1 because of the positive charge, forming 1, 2, 3, 4. Means we will be getting 4 more electrons from the sharing of electron. So this is 4 and 4, 8. So here overall what I have found, its octet is complete. Its octet is complete, but it is 6. So first and third are bit more stable than the second because octet incomplete. Octet incomplete. Second can never be stable. Octet incomplete. Okay. Now out of first and third, okay, second. So my answer could be either B or C. Yeah. A can never be the answer. D can never be the answer. Let's compare between the first and third. Now the second point is number of bond order. Look for the bond order. If you will see, this is 1, 2, 3, 4, don't count this OH bond, because if you will count there, you have to count in every other question. So ignore this OH bond, okay? Let us do it again. 1, 2, 3, ignore this bond, 3, 4, 5, 6, bond order is, here we have bond order 6, here we have 1, 2, ignore this bond OH, because OH is in every other structure, 1, 2, 3, 4, 5, the bond order, why I am comparing for the structure number 2, leave it, leave it, leave it. Don't do this for structure number 2 if it's very clear that the structure number 2 is least stable. Okay, do for the structure number 3rd. 1, 2, 3, 4, 5, 6. Bond order is still 6. So, same. We will be moving ahead with the point number 3. Point number 3 says opposite has to be closer, likes has to be away, but we don't have any other charge. So, charges wala point is not applicable for this particular question. The 4th point says that charge must be as per the nature of the atom. As per the nature of the atom. So if you will see the nature of the atom, what you will see? Here we do have in the structure number 1st. In the structure number 1st, we have a positive over the oxygen. In the structure number 3rd, we have a positive over the nitrogen. So which is better? वैसे तो we would say that the positive charge is not at all stable, neither over the oxygen, neither over the nitrogen, because both are electronegative species. But relatively, we know that boron, carbon, nitrogen, oxygen and fluorine, when we go from period number, in the period number 2, when we go from left to right, the electronegativity increases. Electronegativity increases. So oxygen is more electronegative than the nitrogen. So oxygen should not have a positive charge, right? Nitrogen may have. So over the nitrogen we can put a positive, but over the oxygen we can never put a positive, because oxygen is more electronegative, and over the more electronegative the positive charge must not be there. Okay, so means which is more stable? Nitrogen with positive is more stable. So we can say that the 3rd one, that is out of the 2, the 3rd one is going to be the more stable than the 1st one. Than the 1st one. I hope you got the answer. Why? Because in the 3rd one we have a positive over the nitrogen, which is much stable as relatively the positive over the oxygen. Okay, that's the reason. So just follow all the points. These points are very simple, and this is it. You will be able to solve any number of questions that you will be getting. So there is one probability. Usually, you know why I have come up with this particular session, because whenever there will be a question of resonance stability, I have seen some of the students count the number of canonical structures and then they say this will be more stable. What I mean by this? If a structure is having only 2 canonical structure, and if one of the structure is having 5 canonical structure, then the structure with 5 canonical structure is going to be more stable. This is shit, guys. No, don't do that. Okay. The resonance stability, the stability of the resonating structure is not, it cannot be determined by the number of resonating structures. Okay. The resonance stability can be determined by that whether they have a complete octet or not, what would be the bond order, more number of the bonds, more number of stability, more energy is needed to break those bonds. Okay, the charges has to be closer because they will be having more attraction. There must be the charges has to be as per the nature of the atom. So the stability criteria that I have discussed with you, actually this is what we need to follow, not the number of structures. Okay, so I hope I made a point through this session, and if this session really has helped you, please do hit a like, leave your messages in the comment section. I would love to hear whatever you want to share from you guys. And do follow me on Unacademy, because we do have a lot of courses for you on Unacademy. You can follow my plus courses which I am taking. I might be new over the YouTube, but guys, I'm not new over Unacademy. It's an educational platform, a brilliant platform for all the aspirants for any competitive exams. So we do have a master blaster teachers, those who are taking all the sections of JEE paper, that is the physics, chemistry or maths. So guys, you would be getting from one particular subscription, you will be getting a chance to learn from n number of teachers of your own choice. So you can see that I do have 1 million plus followers on Unacademy, the students, those who are learning from me. And yeah, I will keep teaching and they will keep learning. So these are the heads that they have dedicated to me. So you are just a blink away. Just go to Unacademy and do follow me there. Yeah, this is it. Go ahead, and if you need to open any of my content, okay, whether it's free or it's paid, many of the free content you will be able to access just by using a code Megha ma'am. Okay, and if in somehow you will be willing to get the Unacademy subscription, for that same you can again use my referral code, that is Megha ma'am. This is also my referral code. So this is a code that you can use to unlock any of the session okay, over Unacademy, and to get the Unacademy subscription at a decent rate. Okay, thank you guys. See you in some of my other sessions. Bye bye, take care.